So, Ignite. How many of you all have attended an Ignite night somewhere across the country, cities? How many of you all? Well, if you haven't, which it looks like many haven't, you should actually search these out. And they kind of start about in, I think it's 2006. A friend of mine in Seattle, Brady Forrest, came and found me and said, well, I've got this idea. I'd like to take a bunch of geeks, and I'd like to put you in a bar, and I'd like to run your slides really fast. And I think this will turn out okay. I'm like, really? It's like, sure. Like, you gonna buy me a drink? No. Oh, okay, I'll attend anyway. So Brady put a bunch of us in a bar, and it was a fairly seedy-looking basement-level bar in Seattle, and the most amazing thing happened. We filled the entire bar up. We were over capacity, 200-plus people. It was amazing. I went and did another Ignite talk about a month ago. We filled the King Theater in Seattle, overran it, more than 2,000 people, I believe. And it's been amazing to see what has come from these. And so when we were talking about this year, like, what should we do at the conference? Like, let's bring Ignite talks. So what you're about to see is 4 of the best talks that we found last night. And what you're going to see is a fairly, the concept is we're going to try to enlighten you, but we're going to do it very quickly. So if they blow it, well, it's only 5 minutes. So without further ado, I would first like to invite up Sarah, who's going to be talking to you about backups. Thank you very much.
Thanks, Brian. My company is Blue Gecko, and we do remote database administration, but we also get called in to do lots of emergency support for customers, including situations where customers might say things like, backups don't make me money. So we all know that backups are really important. We want to run things out to tape or out to disk and replicate it off to another server somewhere in a distant spot so that we have options. Ultimately, we have in MySQL 2 different ways, or multiple different ways to produce 2 types of backups. The first being a MySQL dump, which is a lot like saying I have all of the architectural drawings and all of the fabrication drawings, and we'll go ahead and rebuild this. The second option is taking clones. You can do this with DB Hot Backup, Extra Backup, LVM snapshots, but the problem with LVM snapshots, or with clones, is in fact any problems you have are actually replicated in the clones. I know here that I'm preaching to the choir and you all have lovely backup plans, right? All right, some of you have lovely backup plans. So as the converted here, what are we actually protecting against? That would be user error. Be this the junior sysadmin who does something foolish, or the developer from the Facebook slides yesterday where he says, I'm about to do something, do we have backups? And we want to be protecting against these opportunities or these chance incidents where someone goes to import a schema on a production system. And we'll hear more about not testing on production later from Jillian. But importing a schema and saying test schema doesn't actually get you a test schema. This customer particularly did not hit the panic button early enough and overwrote this schema in production and then applied production data against it from his customers for about 5 hours. Blue Gecko was called in, and we actually applied liberally regular expressions to the binary logs and made sure that we were able to identify what was import and parse all of that out so that we actually got the data back for them. The second thing that we spend a lot of time protecting against in this community is hardware failure. And I hope your servers don't look like this, but I've seen some that are scarier. The hardware failure will often give us data file corruption, and corruption in images looks awfully pretty, but if you've ever tried to read a corrupted database, you'll know that, in fact, it is not nearly as pretty in that space. You end up with very strange output or no output whatsoever. In a recovery situation, you're always up against the clock. Time is of the essence, and nobody wants to be down for more than minutes at a time. So we are always trying to find opportunities and options and knowing what our restores should look like and being able to make direction changes immediately if necessary. You've got to be fast on your feet and able to understand what your restores look like, how long things would take from a MySQL dump, from a clone, and being able to recover rapidly. Now, sometimes even having those backups for you aren't enough, and you have to choose new directions and say do a forklift upgrade from 5.0 to 5.1 in order to get partitioning. Because you found out that you found the knee in the hockey stick curve, and a 1 terabyte table on a MySQL import in 5.0 will actually take 4 weeks to import because your B-tree index doesn't stay in memory, and the inserts keep getting longer and longer. So you need partitioning. Oh, the CTO from my first slide, he actually ended up bringing us in. This was secret here. This was an Oracle database. The database wouldn't even open, and in fact, we ended up having to unload all the data from tape by hand using one of the great internal Oracle tools to do that. And from there, we were able to reconstruct most of his data. Let's be clear, it was corrupt. He did, however, spend a ton of money with BlueGecko, which I will never argue with. He also spent a ton of money internally opening up a big fat project to make those backups, make a big backup project, and make sure he had them going forward. So backups ultimately don't necessarily solve every problem for you, but they will give you lots more options, the different colors of the rainbow, the different ways you can restore things, and then from there you're able to make decisions, good decisions, and get your data back ideally as rapidly as possible. So thanks very much, and that's my company and my contact info.
So next up, we're going to have Jerry, and he's going to be talking to us about monitoring. So here we go.
Okay, yesterday, actually, the timing of my presentation was kind of off. So basically and it's not even starting on the first slide. What I'm going to do is actually present 3 concepts I took for other disciplines, calculus, communications, and quantum mechanics, to see how these actually influence and these concepts can be used in monitoring databases and diagnosing database problems. I'm going to use this technique because I learned that while raising and educating my kids, confusing them was actually the best way to encourage critical thinking and thinking outside the box. So, okay, now, yesterday I was behind, now I'm ahead. So the first concept would be actually the fact that when you do show global variables, and this has been actually highlighted in many talks, you only get the values, actually the counters. So using differential equations, which is something actually that Newton contributed to create, allows us to actually measure the change over time, and the change over time is what really we're looking for in most cases. I put the links on my presentation, and so you can go to Wikipedia and learn about the theorems and all the nice, gritty stuff about these things. So you have something like show status like connections, and do you really care that you had 1 billion connections since you actually brought up your MySQL instance, or actually do you care more about how many connections you had in the last minute, 5 minutes, 10 minutes, depending on how your sampling goes? Which actually brings me to the second theorem, which is Nyquist-Shannon sampling theorem. And basically what it means is if you have an event that you can model and it happens on a certain frequency, if you're sampling double that frequency, you can actually get that model. Actually, when I was in college, my teacher, when we were talking about analog digital conversion, said, well, actually to get to a real rate of sampling, you have to sample at 10x the frequency. So here we see samples that are being taken every 4 minutes. The graphic shows a dip every 20 minutes, and since the event is happening every 5 minutes, we're experiencing what is called aliasing. If we would have been sampling, as the theorem says, every 2.5 minutes, we would have the tail of that graphic, which basically shows us that it is actually happening every 5 minutes. So the next actually concept is uncertainty principle from Heisenberg's. And basically means that as you're measuring, you might actually be changing your system, so you're not sure exactly what you're measuring. So it might be very nice to have a show process list every 10 seconds or 15 seconds, but that means that you'll be artificially increasing your connections counter. So if you measure, certain things, basically there are others that you're skewing your measures. So be sure when you're monitoring and you're diagnosing that you know what you're skewing and what no. It also happens that every now and then, you don't really know, based on MySQL variables and MySQL resources, what are you measuring? What's going on? So what do you do now? So the big disclaimer here is, since I work mostly with Linux, these tools, I know some of them exist on Windows on OS X, but you'll have to do the groundwork yourself. But the basic concepts are using tools like that are already on the operating system, like SAR, IOStat, NFSstat, VMstat, or even TCP dump. Actually, Mark Callahan shows TCP dump used with grep and awk on his keynote. I'm more of a GUI guy, so I like Wireshark. So to know how to use these tools, man is your man, and Google as well. So go ahead and do your research, and you'll find awesome things on how to test. So understand the underlying concepts, and do the sampling accordingly. Know what are you measuring, remember Newton. Know when you're measuring, remember Nyquist. And know how you're measuring, which is basically avoid skewing your samples. And of course, using Google for all your research, and make sure that your conclusions are things that are in accordance to what is in general knowledge. And if it's not, blog about it, and Google will pick it up for the next person. So test, interpret, learn, rinse, and repeat.
Thanks very much. I'm glad we actually got the slides tracking at the correct time for you this time. So next up, we'll be listening to Jillian, who's going to be telling us the rules of database operations.
Sometime last year, I started compiling a list of the rules of how to be a DBA based on my personal experiences. But I quickly abandoned it out of the frustration of realizing that they were more about how not to be a bad DBA by not doing as I did, rather than how to be a good DBA. But I think in retrospect, it's actually a good idea for new DBAs to know about the mistakes of their predecessors. Databases are dangerous. So my first rule is don't test on production. And you know this rule, and I know this rule, but your supervisor will walk up to you and say, just run this thing on the live databases. There'll be no problem. And so I showed them. I deleted everything in a very important table. And, first thing I did as a DBA is set up a test environment for that, but it's something I've had to fight for in other organizations. And databases are like heavy machinery, and they should not be operated while drunk or under sedation or if you're sick. And I had followed this rule quite easily up until 2 months ago when I was dealing with really bad burnout. And I was fixing a corrupted table on the slave and then realized this was actually master-master replication. And yeah, dropped a live table for the first time ever. So in the case of when you still have to be at work, but you should not be touching anything, I like to do the perpetual boss key, which is setting up your monitor as if you're working. I open up a bunch of terminal windows. One will be connected to a test database. Another will be tailing a log so that you get some scrolling content. And, it works pretty well so long as you, keep your head upright and try not to snore. And while you're trying to get some sleep there, set up good monitoring. And I like to monitor, redundantly as sort of much as possible because problems will show up in an error log before they affect performance. And you want to make it look like your databases are always running smoothly, except to your direct supervisor. You don't want to be the invisible DBA. You don't want to make it look like you're never having to do anything because suddenly you look redundant, or at best you look like there's no reason for you to be behind in your projects. Oh, so tell your supervisor what you're doing, and also document everything you're working on, and instructions to yourself on how to fix them. Because the 3 a.m. self who gets the phone call doesn't remember what day it is and doesn't remember how to do anything. So we'll appreciate a set of lists of instructions. And own up. You're going to make some mistakes, and you should just admit it, because the sysadmins that you work with will recognize if you're trying to cover it. Oh, and then I have a rule about taking breaks. I don't know. It's important. Oh yeah, so there's a lot of long and tedious stuff that you have to do as a DBA. So everything that you hate to do, just try to script it, make it a cron job. Then you can spend more time watching YouTube, or maybe working on something more interesting. Don't be clever. If you're given a problem that you have to solve, don't come up with the most convoluted, complex, buzzword-filled monstrosity of complexity just to impress people, or just because you're so smart that you can. Because you are going to have to maintain this beast, and your 3 a.m. self is not going to know what the heck to do and which of the failure points to start looking at first. Oh, and so usually in your job description, it'll say you're supposed to help the developers with their SQL queries, but it's easy to forget that, because you'll be spending so much time trying to protect the databases from them. But it's pretty easy work. It's easier for us than it is for them, and they appreciate it. And then sometimes you get presents. I made a joke a few years ago that I required chocolate for helping one of the developers, and then 2 hours later, I found a set of gourmet chocolates on my desk. It doesn't have to be chocolate. I've also received beer. But it's a good idea to give those developers a little nudge in the direction of appreciating your work, because otherwise being a DBA can be a very thankless job. And so that's my list of rules I have so far. I'd like to make it a full article. So if anyone has any suggestions or comments about my talk, I'd love to hear them. Thank you.
Great. So next up, I'm going to provide a little bit of information ahead of the talk. So back in November, I was at the NoSQL talk, and someone said, hey, we're going to do some lightning talks. You want to give a talk? So I was like, I'll jot down some notes real quick. Let's just make fun of something. So I sat around and I said, okay, let's explain to people what NoSQL is. So we have a whole audience at this time of folks who are like very deeply into SQL. And I was like, well, let's explain the NoSQL movement to them. Because, obviously we would need to do this. And from that talk, and some 18,000 YouTube video looks at later, Mark said, well, coming to the conference, I think I'd actually like to explain SQL, because while you did a very adamant job of explaining NoSQL, he was like, well, let me see if I can take a shot at SQL. So Mark, who works at Gear 6, is going to now explain to us SQL. So thank you very much.
Thank you, Brian. As he said, I'm here to explain MySQL and the relational data model and how it works. We all understand it, but it involves, it's worth going over again. It is the consistent transactional data store with schema guarantees that uses the relational algebra to access normalized tables. We use it, we all know it, we love it, it's everywhere. Why do we use it? Well, because it has ubiquitous successor classes and a deep bench of skilled architects, developers, and operations staff. That is, all of us. But it has a problem. When we install it, when we start using it, when the load goes up on it, it's kind of slow. We'd like it to be faster. Well, we make a few compromises, we write some code, we change the rules of the game just a little bit, and it's now fast enough. The first thing we usually do is use replication to do a write master and a read slave, because, we really didn't like the way the accessor class was written, and we wanted to write it over again. So we do that, and, we really didn't need perfect consistency. But sometimes that's still not enough. It's still a little bit slow. So what do we do next? Well, some replication worked before, so lots of replication, lots and lots of read slaves. Spend lots of money, fill your data center up, hire lots of operations staff because that's good for the economy. Give up more consistency, and you really meant to learn a lot more about MatKit anyway. But sometimes it's still not fast enough. Fortunately, there's a piece of magical technology that we all know and love to make it go faster. Memcache. Give up any hope whatsoever of consistency. Rewrite your application from top to bottom, spend more money, figure out how to monitor this thing, and all is well, right? No. It's still not fast enough, and now it's too big to fit on any one machine. What do? Well, we can give up a little bit more, write a little bit more code, and what do? We shard. Spend more money, hire lots of more operations staff, learn more MatKit, and rewrite your entire application. We didn't need transactions. The developers weren't using joins all that well anyway. But now our write master is bottlenecked. Well, we were using MySQL because it's so cheap, and our website's making lots of money. And, scale out wasn't working that great for us, so now what do? We scale up. Spend all of that money, buy bigger servers, master, fast RAID controllers, start buying lots of SSDs, Fusion IO would love us for that, and faster network switches, and it all works great, right? No. Now that we have all these machines that are going down all the time, our users and our bosses are yelling at us, and they've heard about this thing called high availability. And our job was already too easy, so what do? DRBD, RAID, and slave promotion. It doesn't hurt that much, and we all really meant to learn how to rebuild our Linux kernel anyway. All works well, right? Maybe. Well, now that we're at this point, our developers are always bugging us. They want to add more to the schema, but alter table now takes weeks to run. So you have this brilliant idea. You only need to run alter table one more time, rewrite your application again. You take all your data, you pack it up in a JSON object, stick it in one table, and now it all works great. It's fast enough. The developers like you. It scales up. Our boss likes you. Our users like us. And what did we give up? Well, we didn't need the consistency, the transactions, the schema, the guarantees, the relational algebra, the normalized or the tables, but we still can access data, kind of. And, well, we don't have the ubiquitous accessor class because we rewrote it 4 times. But there is still a deep bench of burned architects, developers, and operations staff. That is, again, all of us. But it's none of this NoSQL garbage. Thank you very much.